Alright, we've got a coil here that has got a leak on it. It was a 4-ton coil and it was mounted in the horizontal position in a case. So we've replaced it under warranty, done away with the horizontal drain pan in the case, and we just have the coil itself sitting here. And what I did was I welded shut the two pipes, and I have gone in through this port and filled it with liquid R410a, and just to improve the situation I let it sit overnight and air out, and hopefully we can see what's going on here with this coil. Now when I first charged it with refrigerant, I was getting a lot of reaction from the leak detector, so that's why I decided to let it sit overnight. Now the leak was nowhere near fast enough for this thing to have sat here overnight and lost its charge. Now I did do a nitrogen test just to make sure my welds here were good and that we would only be looking for the leak that we had to begin with. So hopefully we can find where this coil was leaking in the customer's house. And I certainly hope I don't find it on a mechanical joint that could have been repaired without changing it, because we took this thing all the way out of the case and we're getting a reaction there. And I've got the sensitivity on normal, looks like. So let's move it to low sensitivity. And we're still getting that reaction there. And we are not getting it around any of these. And we are getting it almost immediately at the one joint of the TXV there. So not on this side, but definitely on this side. So we'll switch it to high sensitivity just to see if that's any different. Did you see on that? Yeah, it does on that side too, but instantly on this side. So we'll go back to normal sensitivity. And I don't think we have to look any further. Now what I like to do if I find a leak, especially with a sniffer, is I like to also get it to bubble. But if this is just this mechanical joint, then this could have been tightened up out there on the location at the job. And obviously the bubbles will tell us for sure that it's the joint and not some of these welds where these distributor tubes. But it is definitely coming out of that joint right there. So before we put any bubbles there to see, let's just see if we can stop it. Or if we can stop it, you know, as far as the sniffer is concerned. So let's put a backup wrench on the distributor. And let's go here on this nut and just see. Oh Lord, that thing was not even almost tight. And that's factory. I mean, this coil was installed I don't know, a year and a half ago, a year ago. Oh man, that's really gonna stink if I went through all the time and labor and trouble to change this coil for nothing. Now, we could have stopped that leak, and we're just getting residual reaction there. So let's see if we can. I think I got a fan over here. So let's just blow this fan across it for a minute. Just in case there's still some refrigerant hanging around that joint. Thought I had my little ledge to sit on there. And I don't know if the leak could have put some oil there. I don't see any oil there, but I don't know if it could have put some oil there that's and as we can see, for all intensive practical purposes, the leak is gone. And I mean, it was every single time leaking right there. So let's go from normal, let's go back to high sensitivity. And I guess that switches pretty quick. But we're getting nothing. So 2 trips out to that house. One to fill him up and plan on doing the leak search. Another to go by there and for not using the sniffer first and looking in the obvious parts, my tech has determined that he had a coil leak And this is why I like them pinpointed, but we took his word and we changed the coil. Well, he did have a coil leak, but look at that. That's a coil leak we could have fixed. Beyond any doubt, we have seen, as long as that's the only leak on this coil, that we could have fixed that with the simple turning of 2 wrenches that we just saw. So the moral of the story, as they say, would be, when you have a leak and you have determined it's on one component or the other, pinpointing that leak is certainly going to pay off. Had I been there myself, I would like to say I would have certainly found that leak. First thing I do is check obvious joints, welds, then we'll go to mechanical joints before we start looking. Now, a lot of times on a leak, the first thing I do is look around outside and look for oil and look in all the common obvious spots that we've all seen. But we went straight to it on this coil, and that kind of stinks, but there it is. And I'm not going to use this coil anywhere else, but just to test and learn, as they say, I think I will let this refrigerant out and evacuate it to get the residue, all refrigerant, out of it. And then I'll charge it with about 250 pounds of nitrogen and check it once a day for a couple of days and just see if indeed what I believe at this point, which is 2 simple turns of a wrench, a couple of wrenches, and that problem at that house would have been over with, and we would not have had to have gone through what we did to change this coil. The tech that determined the coil was leaking will be back in here in a couple hours or towards the end of the day, and I'll show him what we got. Certainly not gonna be angry or any of that. We want to learn and move forward. So I'll show him this video. And as it started out, that was the main reason we were making videos, were training videos and whatnot. And we've learned that it's fun to share them with the YouTube community and to watch everybody else's. But you just saw me learn another hard lesson, and I don't know how many times I've learned it, is to be thorough and pinpoint things. I'm sure I was pressuring him to get as much work done that day as he could, but nonetheless, quick trip with a sniffer and taking the door off. Now, in his defense, it would have been a lot of work. Got to unhook the flue pipe, move it out of the way, get the door off. These coils are a pain. I'm not really crazy about Train's coils, or at least the case design and all that. I'm not crazy about anybody's, honestly. In the old days, things were a lot simpler to deal with, but they've come a long way, and I believe in the product, and that's what I'll continue to use. But you saw what just happened to me, and ultimately what just happened to Train too. They gave me a warranty coil for this, and so I hope they don't ask for it back. Our deal is we keep these parts for 30 days. And if they don't send me a shipping label, I don't have to put it back in its crate and ship it to them. So let's hope they don't, because there's nothing wrong with this one. I'll be buying a coil. I wouldn't even bother to ship it back to them. So anyway, I'm going to evacuate this and fill it with nitrogen. I think I'll use this little steel piece since it's sitting right here. All right. Boy, it vibrates pretty good. Okay. Got some clutter around here now. Can't even walk. All right, so I'm going to evacuate this now. I've got one of these bullets here in the front. I've got a set of gauges hooked up here that have been tested, and I know for sure these will hold pressure. These have just been serviced. That's what the green dot is for. They just came back from field piece, and they are completely ready to be put in service. This is actually not a startup gauge. It's just a service gauge. This is one of the ones that we leave charged all the time, so it'll have these type hoses and it'll be full of refrigerant at all times. So I'm not going to bother trying to pull it down real low to 500 microns or anything like that. I just want to get the refrigerant out of it and give it a pure nitrogen test. So it's down 1200 microns already. All right, it's 800 and something microns. That's far enough for us to do a nitrogen test. And as you can see, this gauge didn't budge. I unhooked it. It's actually going down. It was at 830 and I unhooked it. Now it's down to 827. Nothing's moving. So we're certainly good for pressure testing here. So that is bouncing from 828 to 827 to 828 microns. I guess you can see that. So that's definitely definitely a good gauge and set of hoses anyway. So let's go ahead and put some nitrogen in this. Real close to 300 there. So that is at 301, 301.1. So what we'll do is we'll just let that sit there. Make sure everything's tight. We'll let that sit there overnight. The reason we evacuated it obviously is to get refrigerant out of it, because nitrogen is an inert substance. It will not react to temperature or whatever else. We're at 301.2 actually. So this should settle in and should remain the same. And about a 24-hour test, I mean, we do 10 minutes in the field, but if it'll stay there for 24 hours, I'm quite sure there was nothing wrong with that mechanical joint. And that's a shame, but let's check this again tomorrow and see.